Okay. And the next three examples, these examples, I wouldn't call them tricky, but you do have to be careful with your rounding because when you're dealing with such large numbers, you don't want to round as you go on to each step because by the time you get to the end, you're going to have rounding so much that it's going to really throw off your answer. So you want to wait until the very end to round. So keep all the digits that the calculator gives you until the very end. Okay, so in this example, it says a car was valued at $42,000 in the year 2009, and by 2013, the car value had depreciated to $13,000. And if the car's value continues to drop by the same percentage, here's a key word, percentage, so we know it's exponential, what will it be worth in 2019? The car was initially valued at $42,000 in 2009. So we're going to let year 2009 be our initial starting point at time is equal to 0. And then it says in 2013, the car depreciated to $13,000. So that means 4 years have passed. So that would be t is equal to 4. So what we have to do is we want to figure out how much the car is worth in 2019. So we have to come up with some kind of equation or model so that we can plug in a value for t for 2019 and figure out how much it's worth then. So if we start in 2009, then the amount of time that has passed to get to 2019 would be 10 years. So once we come up with our formula, we're going to plug in t as 10 to figure out what the cost of the car is or the value of the car is in 2019. So if you recall, our general form of an exponential equation looks like this, where a is our initial value and b is our growth factor. So in the problem, they give us the initial value, that's the 42,000. So what we have to do is find our b in order to come up with our final answer. And actually, I just made a mistake here. Notice, I'm going to point it out that I made this mistake so that try to prevent you guys from doing the same thing. I put an x here. Why that's wrong is because we're using t's for our independent variable in this problem. So I'm going to use my mistake to help prevent you from making a mistake. So I'm going to fix that to t. Okay, so y is equal to, I'm going to put in a is my initial amount, so 42,000, and then b to the power of t. So I'm going to plug in an extra point for my t and y so I can find out what my b is. So the extra point that they give us is that when 4 years have passed, the value of the car went down to 13,000. So I'm going to put in 13,000 for y. And I'm going to put in 4 for t. So here's where we have to be careful. When I go to solve this for b, I want to make sure that I don't start rounding with every step that I go through, and so that it rounds so much during those intermediate steps that it throws my final answer off. I want to just put the whole thing in at the end on my calculator to save myself that problem. So instead of actually doing the calculation on my calculator, I'm just going to leave it as 13,000 over 42,000. And I'm not going to actually put that in on my calculator and round it. So I'm going to solve for b to the fourth by dividing both sides by 42,000. I'll finish it up here. And then to finish solving for b, I need to raise both sides to the fourth root. So I'm going to put in 13,000 over 42,000, and I'm going to raise both sides to the 1/4. That way I get rid of that fourth power. So now this is what I'm going to put in the calculator. Okay? And so I want to make sure I keep all the digits that the calculator gives me. And so when I put that in on the calculator, I'm going to get, that's going to give me 0.74588788202. And that's all the digits that the calculator gives me. And I want to keep all of them. Okay, so this is our value of b. Now, if you know how to use the store function on your calculator, you're more than welcome to store that answer in on your calculator so you don't have to type it all out again. But you don't have to. It's just a nice handy tool if you know how to use it. If not, don't worry about it. So here's our equation. We have 42,000, that was our initial amount, and our b, which we want to keep all the digits to make sure we don't have any rounding errors, and that's to the power of t. So here's our model, here's our equation. But now we haven't answered the question yet. We're almost there. Remember what the question was. It said, what is the worth in 2019? So in 2019, that's when 10 years have passed. So I want to make sure I plug in 10 for t and figure out what the value of the car is in 2019. So I'm going to plug in, keeping all the digits. I know it's kind of a pain in the butt, but it keeps your accuracy. I'm going to raise all that to the 10th. And when we do that, we are going to get $2,238.64. Now, your online homework system is sensitive. So if you don't keep all your digits and you start rounding too much and you wait, you don't wait till the end around, then it's probably going to throw your answer off enough that you're going to get it marked wrong, even though maybe you did it correctly and it was just a rounding error. So be sure to keep all your digits until the very end. Okay, for this example, it's called a present value example because we're working backwards. And the majority of the examples we've done so far, we've given you the principal amount and the time and the rate and all those sorts of things. And we asked you what happens, what's this amount in so many years? So in this problem, we're working backwards. We're giving you the amount that you're going to end up with, and we want to find the principal or the present amount. So it says Jamal wants to save $47,000 for a down payment for a home. So the $47,000 is what he wants to have in the future. And a lot of times you'll hear that this is called the future amount because of that. But really what it is the accumulated value. That's your A of t. Okay? It's giving you the A of t or your future amount. Okay, it says how much does he need to invest, meaning how much does he need to initially put into the account if he has a 10.4% APR, it's compounded daily, and he wants to reach his goal in 10 years. So under these conditions, we have to figure out how much he has to deposit so that it can sit in that bank account and earn him enough interest that he can have $47,000 in 10 years for that down payment. So we're going to plug all of this into our formula. This is a financial application, so we're going to use one of the two formulas, compounding or compounding continuously. This doesn't say it's compounded continuously, it says it's compounded daily. So you want to use the formula that has the n in it because the n is going to be 365. Okay, so we're going to use this formula. And the A of t, which is our future amount, that's what we want to have in the future, our accumulated value, that's going to be 47,000. The principal is what we're looking for. That's our starting amount. So I'm going to leave that as P. The rate that they give us is, 10.4. So I'm going to put that in as 0.104. It compounded daily, so my n is going to be 365. And so I'm going to have 365 times 10 in my exponent because this is going to be going over 10 years. Now again, this is one of those problems that could get sensitive with rounding. So I would not do this part first, round it, and then divide again. What I would do to make sure you keep all those digits is put it all in the calculator at once. So I'm going to divide both sides by 1 plus 0.104 over 365 to the power of 365 times 10. And I'm going to put all of this in the calculator all at once to maintain the accuracy instead of dividing by a rounded number and then rounding again. So when you put all that in the calculator, just be sure, I'll put in my extra parentheses down here, you put parentheses around the entire denominator just like this so that it knows that whole thing is in the denominator. Okay, when you do that, you should get $16,614.83. So what this is telling me is if Jamal puts in the bank right now, this is our present value, which is easy to remember because it's a P, it's principal present value, okay? If he puts $16,614.83 in the bank right now, then under the conditions that they're talking about in here with daily compounding and the 10.4 APR, he will have $47,000 in 10 years for that down payment. Okay, last question, which again is sensitive to rounding, so we're going to be careful and wait to round right at the very end. Now, this one isn't difficult, but there's a lot of steps. So you have to really take your time and pay attention to what you're doing. Okay, it says Kiko has $15,000 that she wants to invest. Her bank has several accounts to choose from, and her goal is to have $20,000 by the time she finishes graduate school in 5 years. We need to find the minimum annual interest rate in order for her to reach her goal. So in this one, they're asking us to find the rate, which is R. So it's going to be a little bit more messy and more steps because we're going to have to rearrange the formula a little bit more than the previous two examples. So they're giving us, so here's our original formula that we're going to use. Because it doesn't say it's compound continuously, we're going to use this formula here. And we're trying to solve for R, because it's asking us to solve for the interest rate. So the $15,000 is what she wants to invest. So that's my principal. What she wants to have, her goal at the end is $20,000. So that's what we're going to put down for our accumulated value is $20,000. She's going to graduate in 5 years, so she wants to have this in 5 years. So T is going to be 5. And let's see. It says it's compounded daily. So N is going to be 365. N we said is 5 because she wants to do this in 5 years. So we have 365 times, and then T is 5 because she wants to do it in 5 years. So we have this big mess here, and what we're trying to solve for is R. So the first thing we're going to do, again, we're not going to put anything into the calculator and round it until the very end to save all those decimal values. So the first thing I want to do is I want to get rid of this 15,000 and divide both sides by 15,000. So I have 20,000 divided by 15,000 is equal to, and then I'm just left with the parentheses over here. When I take 365 times 5, that gives me 1825. Okay. Now, in order to get the R from inside the parentheses out so I can solve for it, I need to get rid of that exponent of 1825. Now, just like if I had before b squared or b to the third, we want to raise it to the reciprocal. And although it's a big nasty number, it's still the same procedure. So I need to raise both sides to 1 over 1825. So messy, but not hard. So raising both sides to the power of 1825. So that gets rid of these. So now I'm left with 20,000 over 15,000 raised to the power of 1 over 1825 is equal to, and then I have 1 plus r over 365. So now to keep solving for r, I'm going to subtract 1 from both sides. Finish it up here, we're almost done. And then the last step is to solve for r, is to multiply both sides of the equation by 365. So I'm going to have 365 times 20,000 over 15,000 raised to the power of 1 over 1825 minus 1. And that's all equal to my r, because when I multiply both sides by 365, I get rid of this 365 down here. So be very careful when you put this in the calculator. You want to put it in as 365 with parentheses, then another set of parentheses for the 2,000, or 20,000, sorry, divided by 15,000. Then raise that to the power of 1 over 1825, then minus 1, and close parentheses again. So be careful about how you put it in. That's the only thing that's really tricky with this one, is the rounding, and when you put it in the calculator, it's a little bit messy, so you have to take your time and make sure you put parentheses in the right places so you get the correct answer. Well, when you do that, you get that r is equal to 0.102-179-4243. And then the answer says round it to the nearest hundredth of a percent. So if I multiply by 100 to change this to a percent, I would get 10.2179423%. And then when I round it to the nearest hundredth, that means 2 places. So my final answer is going to be 10.22% if I round it to the way the directions asked me to.